Picture this. You're visiting your absolute favorite, totally secure banking or crypto website. A super familiar prompt pops up on the screen asking you to quickly re-verify your password. So you type it in, hit enter, and just like that, your credentials are gone. Stolen. But how? You were definitely on the correct website. The URL was right, that little padlock icon was right there on the corner. Well, what happens when a trusted website asks for your password, but it wasn't actually the website that asked?
Welcome back to The Explainer. Today, we're tackling days 11 and 12 of our series based on Peter Jaworski's incredible field guide, Real-World Bug Hunting. We're zeroing in on Chapter 5, exploring two really fascinating, highly deceptive vulnerabilities, HTML injection and content spoofing. Okay, let's dive into this.
Section 1. The concepts. Defining the threat.
So, before we jump into the real-world bug bounties, let's get our definitions straight. At their core, both of these attacks rely heavily on social engineering, tricking users by manipulating a web page's underlying structure. But we have two distinct flavors here. Think of HTML injection as basically digital graffiti. An attacker uses actual HTML tags to alter the structure of the page itself, literally building fake doors or input forms right on top of a perfectly legitimate site. A lot of folks call this virtual defacement. Now, on the flip side, content spoofing is a bit more restricted. It's essentially just plain text injection. In this scenario, the server actually strips out or escapes the HTML tags, so the attacker can't format the page or build those fake forms. But they can still inject plain text messages to manipulate and trick unsuspecting users.
And this brilliantly illustrates exactly what content spoofing looks like out in the wild. This is an actual bug bounty example from a site called Within Security. A hacker figured out that during a WordPress login error, the site was reflecting URL parameters directly onto the page as plain text. So, by just tweaking that URL, the attacker was able to inject this incredibly convincing yet totally fake warning message: "Your account has been hacked, please call us," right onto the official login page. There are no fake input boxes here, just plain text trickery used to phish panicked users. And the hacker netted a cool $250 bounty just for this clever little lie.
Section 2. The workaround. The Coinbase case study.
Okay, so what happens when an attacker really wants to build those fake doors, but a site is actively trying to stop them? Let's take a look at how a very clever hacker managed to bypass Coinbase's basic HTML filters. Here's the step-by-step methodology they used. Normally, Coinbase did a great job filtering out plain HTML to protect its users. If you try to submit an H1 tag or a form tag in a user review, Coinbase would just strip it right out. But the hacker noticed a tiny, subtle detail. If they took that exact same HTML and encoded it into numeric HTML entities, so a character like a less than sign becomes &#60, the filter completely missed it. Step 3 was the absolute jackpot. The Coinbase server took those numeric entities, completely decoded them back into HTML, and then rendered it live on the page.
Look at this. This text right here is what the hacker actually submitted to the server. I mean, it just looks like absolute gibberish, right? A massive, confusing string of numbers, ampersands, and semicolons. To a basic security filter that's just looking for standard HTML brackets, this looks completely harmless, but it's actually a Trojan horse. Let's see what happens when the vulnerable server processes this exact string.
Boom. The server decoded that gibberish straight into a highly dangerous fake login prompt. The decoded payload literally translated to HTML input tags for a username and a password. And because this was rendered directly on Coinbase's actual trusted domain, a user reading the review would just see a perfectly normal-looking login box. If they were fooled into typing their credentials in, well, that sensitive data could be sent straight to the attacker. Coinbase ended up awarding this hacker a $200 bounty for finding this incredibly clever encoding bypass.
Section 3. The patch illusion. A HackerOne case study.
When a company deploys a fix for a flaw, we all just assume the platform is secure now, right? Well, not exactly. Let's look at the timeline of a digital detective story involving the bug bounty platform itself, HackerOne. So first, a bug hunter finds a vulnerability in how HackerOne's Markdown editor parsed single quotes, which could potentially be used to steal user data. HackerOne recognized the risk, paid out the bounty, and deployed a code fix to patch it. Most people would call it a day right there and assume it's safe. But the author of our source material, Peter Jaworski, well, he knew better. He decided to immediately jump in and retest that brand new patch. To really stress test this fix, Jaworski submitted this highly confusing string of Markdown right into the editor.
Normally, a link in Markdown just has a URL and a title enclosed in double quotes, but Jaworski deliberately injected extra random double quotes and weird attributes like ismap and a completely fake attribute called YYY, just to see if he could confuse the newly patched parser. He essentially wanted to know exactly how it would handle unexpected, totally malformed input.
Now, what's really interesting about this is the beautiful irony of bug hunting. Jaworski's confusing input actually broke the new patch. The fix that HackerOne just deployed inadvertently created a brand new vulnerability called an unintended HTML include. By trying to fix the single quote issue, the developer's new code got totally confused by the extra double quotes and accidentally started generating arbitrary, unescaped HTML tags. The fix literally created a brand new backdoor for attackers to inject code. Wild, right?
And because of that persistence, HackerOne actually had to revert their previous fix, implement a completely different solution, and they awarded Jaworski his own $500 bounty. He got paid $500 simply for proving that their brand new patch was mathematically flawed.
Section 4. Key takeaways. The hacker's mindset.
So, whether you're a developer writing the code or a security enthusiast looking to secure it, what should you really take away from all this? It boils down to this fantastic quote directly from Peter Jaworski's book: "Just because code is updated doesn't mean all vulnerabilities are fixed. Period. When a patch is deployed, it inherently means there is new code on the server, and new code means the potential for new bugs." The HackerOne example proves exactly why absolute persistence is absolutely crucial in bug hunting. You can't just test the original input. You have to test how the system handles weird encodings, like we saw with Coinbase, and how it handles completely unexpected malformed input.
Which leaves us with this final, somewhat provocative question to chew on. When a vulnerability is officially declared fixed by a major platform, who is actually checking the developer's math? The cycle of cybersecurity is continuous. Every patch is just a new beginning, a brand new puzzle waiting to be solved. So keep questioning, keep testing, and never assume a closed door is actually locked. Thanks so much for joining me for this explainer, and definitely keep your eyes peeled for those fake forms.